Okay. All right, we're all ready to go, I think. Today is Ask Your Questions Day. We are finished with all the chapters. So, whatever questions you may have, it is now time to ask them and we'll answer all the questions. What do we got?
I just have number 14.
Number 14? Okay. Let's see. Where did it go? Here it is. Chapter 17, number 14. Okay. So here we have two instruments playing two notes, and they want to know what is the wavelength, and they tell us the frequency. So what would you do to calculate that? There is this equation that relates three things. It relates the speed of the sound, the velocity of the wave, the frequency, and the wavelength. This is a lambda, by the way. So the velocity of the wave equals frequency times wavelength. They've given us the velocity of the wave right there. And they've given us the frequencies. Is that what you did? And it didn't come out correctly? Okay. Well, let's do the calculation really quick and see if we can test out this code. We have 343. And we're going to divide it by 293.66. Should come out with two significant figures when done right. Three significant figures, rather. And so for the first one, I'm getting 1.166. No, 1.168. So 1.17 would be my first one for this. Let's take a look here. Yep. So if you put in 1.17 or 1.168, probably that would work. How many significant figures did you use?
Well, I guess I use wavelength equals velocity times the period because I converted it into.
So you just took 1 over the frequency to get the period? That also works. You can also take the...
My formula would be different.
No, it's the same formula.
Not for because my.
That's the one you used?
Yeah.
That's the same.
Oh.
That's the same formula because the frequency equals 1 over the period. So that ends up being the same. This formula gives me wavelength equals velocity divided by frequency. This one is also velocity divided by frequency because period is equal to 1 over frequency, or frequency is 1 over period.
Yeah. Wait, so how many significant? Because I had.
What are your numbers?
My velocity is 3.3.
Okay.
And my wavelength is.
Do they give you frequency or wavelength? Okay.
698.46.
698.46. Okay. So you would take 343 divided by 698.46. And I'm getting 0.491. 0.4911. Is that what you got?
Yeah, I rounded to 0.496. zero when I did it, when I converted my period, when I converted frequency into a period. So I don't know if
So my guess is that the answer should be 0.4911 in the end.
yeah, that's right.
Is that correct? It's just, yeah, you just rounded incorrectly, I think, in the end.
For the last part, do you just add the frequencies together, correct?
You actually take the difference in the frequencies for the last part.
Oh, okay.
So the beat frequency is the difference between the two frequencies.
Oh, okay.
And you can actually hear, it's actually pretty easy to demonstrate a beat frequency, even through like YouTube, for example. Too many toolbars. So what they're going to do here is they're going to play two different notes together. These are just two tuning forks that are identical, but on one of them they put a little slider that makes this one a little bit out of tune with the other one.
So I'm going to demonstrate the phenomenon of beats.
Don't need to hear you talk about it. We already know.
Following phenomenon.
Oh, we can't hear it.
Can you hear a wow, wow, wow?
Needs to be louder. Need a louder version of this. I used to have all my stuff connected to these speakers in the room, but it's all been disconnected. And so I don't have very good speakers in this room anymore. I was hoping that this would be a louder kind of speaker monitor, but it's not. There we go. So this is when you just hear one of them. This is just one of them. And that wah, 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 wah is the beat frequency. That's the thing that's doing the beating. And the reason that it's doing that is because the overlap of the waves creates constructive interference sometimes, so it gets louder, and destructive interference sometimes, and it gets softer. And that softer, louder has a fairly recognizable frequency. It's something that we can discern with our ears. It's usually somewhere between like 1 hertz and 0.1 hertz or something like that. That one there was probably pretty close to about 0.2 hertz, I would guess. So about 5 beats per second. Anyway, that's the beat frequency. Any other questions?
Number 15.
Ah, yes.
Oh, that is not what my number 15 looks like at all.
That's probably because this is the wrong assignment.
Oh, okay.
Well, I think it is anyway. Let's see. That's the last chapter. I got too many windows open. What am I thinking? Here we go. Okay, so this one has to do with the idea of what intensity is. So intensity is equal to the power over the area. And we're talking, so the area is like, you could think of the area as, let's see, what's the best way to think of it? Think of it as you have a person standing here and they're talking, and as they're talking, sound waves are moving away from them, and these lines represent the peaks of the sound waves, or the high pressure part of the sound wave. They're moving in every direction, right? In kind of this sphere outside of them. And then you blow up this huge balloon and you cover it out here. And this huge balloon out here, let's draw the balloon in a different color so that it makes more sense for us here. So balloons are supposed to be red. So we put this big balloon out here, and the surface area of that balloon would be the area in this equation. That would be this area, right? And from this person's mouth out to here is the distance r that they're talking about. That's so move 3 times further. So if you put a balloon out here that's 3 times as far away, and this is little r and this is big R, and big R is equal to 3 times little r, what is the area of this balloon? How is the area of this balloon going to change? Well, for the area of a sphere, the area of a sphere is pi, let's see, it's 3/2 pi r squared or something like that. I can't remember exactly what it is. I think it's 3/2 pi r squared. I don't know exactly what the numbers are out in front, but the area increases as the radius increases squared, right? So in other words, if we go from r out to 3r, the area of this big one is going to go like this. It's going to go like pi. It's going to go like no, it's not. I know what the area is. It's not 3/2. It's 4 times pi r squared. 4 pi r squared. So the area out here is going to be 4 times pi times big R squared, but big R is little 3r squared. And so the difference is going to be this. The area of the little one is 4 pi r squared, little r squared. This one's 4 pi times 3r squared, and that's 9r squared. So the area here is 9 times bigger. And if you plug that into this equation, this all of a sudden becomes 9 times smaller, right?
Oh,
So the
so
intent,
my number is 6, and I put that it was 36 times smaller.
so this says 36, this says something times what it was, right? So, and
Yeah.
how to do this. Over here, we're giving, so you said decrease.
Yeah.
So let me choose that. So you would do decrease 2, and then you want to do 1/36 times what it was.
Oh, times.
So it's 1/36, it's not 36.
Oh, gotcha.
That's a reduction, right?
Okay. So, okay, got it. I
Yeah,
just skipped a step.
yeah, I just have to get the math right a little bit there. Oh,
My next question is 16, if no one else has questions.
we can do 16. All right, so the sound intensity level is the dB equation. You remember that equation? So
No.
in dB, the equation is in chapters, it's in this one right here. Nope, it's not here, sorry. I lied. It's here. 17.3. The sound level is measured using the intensity. So you have to know the intensity. And
Okay.
you also use this equation here, which this gives us the sound intensity level.
Oh,
This
right.
statement here is the sound intensity level. And you do the log base 10 of the intensity of the sound over I naught, which is the lowest intensity of sound that we can hear as humans at a frequency of 1,000 hertz. So so that number I0 is actually 10 to the minus 12. And then you just plug in your numbers. Can you do that, or do you want me to do it?
Yeah, let me try it. Maybe I just did my calculator wrong or something.
Okay.
So I would do 10 log base 10 is just 10, right?
No.
So
So-
I think that's my issue in my calculator.
Okay, so what you need to do is you need to first, so you need to put this in. So what kind of calculator are you using, first of all?
Um,
Looks like, is it a Texas Instruments?
Yeah.
Okay. So the Texas Instruments calculator, what you want to do is you want to type in 10 times, do 10 times, and then the log. Now there's two logs in here. There's the regular log, and then there's the natural log. So it should be the LOG one, not the LN one. So you're gonna do,
okay.
and then inside the parentheses, that it should open up some parentheses for you for that, right? Then inside those parentheses, you'll put in your intensity that they give you, and then divide by the 10 to the minus 12, and then close the parentheses after the log, and then hit enter.
Okay.
And that's how you'll calculate that. So this is the argument for the log, is the I over I naught. This is the thing that you're taking the log base 10 of. Then after you've taken the log base 10 of whatever number's in here, then you'll multiply by 10 when you're done.
Wait, and then multiply by what?
So then you'll multiply by this 10 on the outside after you're done doing the log of this stuff on the inside. So what the calculator does when you finish this is it will take the logarithm of this first, and then it will multiply by 10. That's what your calculator is going to do.
Okay.
So if you typed it in correctly,
Okay, let me try that.
and it should give you a number between 0 and like 120-ish.
Okay. Okay, yep, I got it that time.
Okay.
I was just typing it into my calculator wrong.
Any other homework questions?
Okay, well, I had a question on 17, but now that I know how to do my calculator, I should be able to get it.
Okay.
Can we do, oh,
Go ahead. What?
When I first attempted to do it, it only let me enter like one choice, and then it like
Which one?
12.
Number 12?
Because all I gotta choose is my first option, and then it's name my answer.
Huh. That's weird.
And so then I would do it again.
So you could only do like this is second or something? Or what? No, you went and did your first one first, right? So you said this is my first, and then it's attempt, then it submitted automatically. Huh. That's weird.
Like glitch or something. And sometimes like when my phone do it, it'll like, if I haven't answered a question, I'll notice that like this submit button like starts to change it.
Huh.
And then my target will say like how it's.
So did you try it again and it did the same thing, or is it?
No, the second time it was fine, but I only got it like insert like.
So you just lost some points for no reason, essentially, right? Okay. Yeah, just send me a quick email and just tell me that so I remember to change it later. I'll fix your score on it later. Any other question?
yes, could we do number 11? Am I supposed to use the closed at both ends equation?
So this one is a string.
Okay.
So a string a string is um, I'm trying to start open up a pen, but I'm not going to use a pen. What am I thinking? Okay, here. So when a string makes a sound, it's tied down at both ends, right?
Yeah.
And so the lowest uh, frequency or the longest wavelength, let's see, so we're doing frequency. So the lowest frequency is when n equals 1, and that's this one here, where it's just going up and down like this. And so the full wave is like this, right?
Right.
N equals 2 is when you can get the full wave in here like that.
Uh-huh.
And n equals 3 is when you can get 1.5 waves in like this, right? So at the n equals 3, we've got 1.5 waves fitting in here. So that's going to tell us the wavelength, right? Because that means that if we have 1.5 waves in here, then 2/3 of this is a wave. So our wavelength is going to equal essentially 2/3 of 0.77. Does that make sense?
Yes. Okay. I was trying to use the equations it gave us in the book,
Well,
and that really didn't apply to this problem, I don't think.
you can use them, but it's just a little bit, it would take a little bit of solving to do it. I would just look at the picture here. Looking at the picture, I can just figure out that this is 2/3 of this distance, and that gives me the wavelength. And then, of course, the frequency is equal to the velocity of the wave, velocity of the sound divided by the wavelength.
Okay, so my first one is N1. So my measurement would just be the one that it gave me.
So no, because if it's n equals 1, it's a string, then your first wave is the one where it just goes like a jump rope up and down.
Oh, so
This is
double
almost,
it then.
yeah, this is only half a wave. So your wavelength would be 2 times the length of the string.
Okay, and then my last one is 6.
Yeah, so
So
six,
I do,
6 is a little more challenging because you have to go through 4 and then
right,
equals 5 and then n equals 6. So at n equals 4, you have 2 waves in here. At n equals 5, you have 2.5. At n equals 6, you have 3 full waves in here. So you would have your wavelength is equal to 1/3 of 0.7 of your whatever your length is, because there's 3 full waves on the string at that point.
oh, okay. Got it.
Excellent. Any other questions?
On number 5, would I use the base equation or use like a closed on one end, open on one end?
Pouring into water into a long tube, pitch of the sound the water gets higher as the tube fills. Yeah, so this is a closed on one end, open on the other end tube.
Okay,
She's pouring the water in one end, so it has to be open there, right?
right.
And so so at different lengths, you'll be able to now the pitch that you're going to hear is going to be the fundamental pitch. That's the one that's the most likely. So you're going to fit a 1/4 of a wave into whatever length they give you here. So the wavelength will be 4 times these numbers every time.
Okay. Okay. Okay, Oh, and then I guess on number 3, I was confused because I feel like it's asking for some of the same numbers. I'm not sure what I did.
So, so in this case, and this is an experiment that I wish that we could do, and I was trying to figure out if we could do it with our cars, with the cars that I gave you, because the cars do have a speaker on them, I believe. I'm not sure how to change the frequency of the sound of the speaker. But and I don't know if anybody's done an experiment like this, but the what's going on here is they've got this tube here, and it's open on both ends. They put the speaker in here. The speaker over on this end, they put some frequency in here. And as you turn the frequency from very low, you start off very, very low, and you slowly turn it up, you'll eventually hear it get louder all of a sudden. You'll just hear it go, right? And as it does this, that means that you're resonating. Now, the first place that it resonates inside of an open tube, open on both ends, you have to consider that the pressure is going to, you're going to have half a wave fitting into an open-ended tube, because it has to go, the pressure has to go down to atmospheric pressure at both ends. So you're going to have a wave like this going through a tube open on both ends. So the lowest one, the n equals 1, is going to fit half a wave in there. So the wavelength of n equals 1, lambda 1, is going to equal 2 times the length of the tube, right? The second one that you're going to fit in here, since it has to go down to this pressure that is, since it's open to atmosphere, it has to go to atmospheric pressure, which is going to be kind of this middle pressure here, is going to be the one where it goes up, down, and then back up to here again, right? So that's lambda 2 is going to be 1 full length. And then, of course, it goes up, down for the third one. And that's 1.5 waves in there. So that's where lambda 3 is equal to 2/3 of the length, and so on, right? For that.
Mhm.
And so that's the same kind of thing that you're doing here. And then with each one of these wavelengths, if you know the speed of sound, you can calculate the frequency. Or if you know the frequency, which you do for the first one, you can calculate the speed of sound. So for the first one, you know the length and the frequency, you calculate the speed of sound, and then you can use the speed of sound to calculate the frequencies that will resonate after. Now, which frequencies will resonate after? All of these frequencies will resonate after.
Oh, okay.
These are the ones that fit in the tube just right, so that they'll resonate. For a closed tube, of course, it's different, because for a closed tube, at the end of the tube, you're always going to get high frequency, you're going to always get high pressure, but then it has to go down to that, middle pressure at the outside of the tube again, right? So this is only 1/4 of a wave fitting in for n equals 1. So that means that the lambda 1 is equal to 4 times the length of the tube. And then the next one, you can go, it's this one here for the next one, like that. And that's 3/4 of a wave fitting into the tube. So you have to take 1/4 more of the tube's length to get, so that means the lambda, and you can calculate these again using the equations, but
Okay.
makes sense?
Yeah.
Any more questions? You got any more questions here? No?
No.
Everybody's good to go?
Yeah.
All right. Do you have any questions from previous chapters or anything else for the final or anything?
Yeah. Are we gonna meet for class on Tuesday?
Nope,
No.
unless you want to. I mean, we can if you want to. We can meet and you can ask questions about the final if you want to. But we don't have any scheduled class times. we're done until the final. I mean, you can just take the final whenever you want. You're good to go.
Okay, what day is the final due on?
Do it by Thursday. Do it by
Okay.
by end of day Thursday.
Okay.
Any other questions? All right, well, it's been a pleasure to teach you guys. Thanks for being in my class. Make sure that you finish, if you haven't finished all of your lab work, please do so. And then please return lab equipment to me as quickly as you can so you don't forget. And if you need to pay to have it shipped back here, for example, just ship it back with a receipt for the shipment, and I will get you a refund for that shipping. And or you can drop it by at the college if you're in town, or you can hand it to somebody that's coming here and they can drop it by or something like that, but whatever. And thank you once again. I do have the second half of this class running in the summer if you decide you need it or want it. I do have one student in the class. And besides that, best of luck in your future education and your plans. And if you ever have any questions that I can help you with or anything that you want, I'm more than willing to give letters of recommendation to students as well, things like that. So feel free to call or email or whatever. Have a great career. Hope to see you soon. See you later. Let's see, what am I doing here?